Okay. Okay, so chapter 5 is fairly short. It seems very long in the note document because there are a lot of screenshots. So this time I try to take a little bit more of the image shot so you can see. But in this chapter, we're going to talk about investigation process on how to really map out the timeline, because it's important that you understand the sequence of action when you're investigating, and that saves you time and it minimizes the error. So we have to take a look at, what had happened to the artifacts. And in this chapter, it talks about the tool that's incorporated in some of the toolkit, like XWays and Plaso, to really map out the timeline, like when did they delete the files, like what kind of things were moved or changed, things like that. So we have to really map out the sequence of action in the investigation, so that way we can go through that sequence as we are searching for the artifacts to build the evidence for the investigation. So in the search method, you really want to limit your scope to the type of investigation that you're doing. And in digital forensic, a lot of the times it could possibly deal with like breach case, it would deal with malware case, it will deal with fraud case. So the nature of the case really determine on how we would search and what kind of scope that we would look into. Because if you start looking everywhere, it will be a waste of effort and it will be a waste of resource. So what we want to do is we really want to establish a timeline. And at the beginning, it talks about how you can create a timeline and what should be in the timeline. So a timeline is a way that we would analyze what the system has gone through, because in the system, we would usually look at, RAM, hard drive, and records, logs that would be generated based on the actions that the user initiated in that system. Okay, and that's going to tell us where the evidence would be, or where we would be able to gather our artifacts. So in the timeline analysis, you need to look for 3 areas: the modified, the access, and the created. Okay, and all of these things would have some kind of record, some kind of logs, timestamps that would tie to them. So if we're looking at files, then we would say, okay, when was the file created? When was it modified or edited? And was it accessed, and how was it accessed? So with that, what we can do is, once we establish the timeline, let's say that the file was created last month and it was edited last week and it was accessed today. So the flow would be create, edit, and access, right? And so the file doesn't exist until it's created. And once it's created, they need to modify it. And once it's modified, then they can access it. Possibly could be for sending it as an attachment, right? Transferring the file to another location, etc. So with that, what we have to see is we have to map it out so that way we can follow that breadcrumb and we can build up more information about such file. Okay, so let me go into my I'm sorry, I'm in the wrong folder here for my other class. So in the first question, it asks you to find MAC times. And why is MAC times important in the investigation process? So MAC times refer to modified access created times, right? And you would find this in, file system logs. You could look at your overall system logs to look at the application that is launched using that, to open or create files. So it tells us when the file was created, when it was accessed, and when it was or when it was modified and when it was accessed. It is important because as part of the process, we really want to establish the records of the occurrences, right, in chronological order. And that's important to understand that because we would investigate based on the course of action over time, right? Historical action, of course, because we are just looking back into what had happened. So the MAC times refer to modified access created times or logs, right? Timestamp of specific object. Okay, and in digital world, a lot of times we tie things back to files, right? The location of that files, the content of that file. So that would tell us where to go in the file system to really see if it was created, edited, or accessed. Now, let's say that you have a user that created a file, right? Save it, modified it, sent it, and then delete it. You would have the chronological order of all of those things. So we would be able to find the logs, okay? Now, some of this, you know, the example that the author used is that he went back and he investigated based on the testimony or the account of somebody else. So they were investigating the child abuse case, and what he did was he went back and he looked at the web search history on that computer based on that scope of time. So the spouse had mentioned that, you know, the child got hurt during this period, and so he had that initial point on where he would start. And so they looked back in the search history for, you know, child injury and how to fix child injury, and he was able to pinpoint the time that it occurs. So sometimes that can go back to your web search history, right? Or it could be a physical file on the system when we're dealing with other cases. So it's important to really establish that so we can map out our process in the investigation. And the resources that we would use to determine the context of what had occurred with that artifact is we would use event logs. And when you're dealing with Windows system, right, you would just go to event viewer and you would be able to find that. And you can, if you search for event viewer on your search bar, right, then you would be able to open that up. And there are other ways to open up the console, of course. Then we should also look at file system logs. Okay, this should be together. Or in some cases, we would look at the internet history. So if they're using multiple browser, we should go in and look at the browsing history and to determine what did they look for, especially when you're dealing with, you know, like murder crimes, stuff like that. A lot of times people tend to search for those things. Okay, how to commit a murder a certain way, or they would search for equipments, tools, where they could be able to locate that location, things like that. So what that will do is we would establish a super timeline, okay? And the logs is going to tell a lot of the story on what had happened, what type of occurrences occurred on that system. So we can have a layout of the timeline, which is known as the super timeline. So in the first page it talks about that, and you can find the answer for number 2 right there on page 1. And what does that give us? That gives us the data points on how you can look through, or the data points so we can look through it, because that could be a lot of things. So we can sort through it and filter out the things that we don't need and look at the essential data that's going to give us a big chunk of our artifacts. Okay? So now there are some examples. He mentioned that you don't have to look at the content of the file. You can simply say what kind of file it is, how it was created, when it was accessed, and when it was modified to really build the case or the evidence for that case. So there are different types of tools for us to go about doing this, and some tools would come equipped with a way that we can create a timeline. So XWay has a feature called event list, and this would look at different areas of the system and timestamps to build an overall picture of what had occurred with things like emails or files or registry or browsing history, etc. So it gives you the options to select for the event. Okay? And it would present to you in chronological order based on the timestamp. So you would see the earlier first, and then you would see more of the recent toward the lower part of the list. So this is how XWay would be able to assist the investigator in establishing the sequence of events. So a screen capture of this would be like this, of XWay. Okay. Now they highlighted the little calendar so that way you can scope down your date range. And remember, we want to use UTC, the universal time, instead of our time zone when you investigate. So that way it will be a neutral time zone. So you can specify the range of the date, and what the system, the application will do is it's going to organize the sequence of the logs, and it's going to present that to you. Okay. So here in this picture, what we see is we see different year, and then we can specify the time, the timeline on what we want to look at. Okay. And so with that, what we would have is we would have a data point, right? Like if for that case, it's going to present to me what kind of data that I'm looking at chronologically. Then we can start looking into the file and the file names. Okay. So here it shows you on what that would look like. Okay. So what that does is it builds a list for us, and then we can use that list to narrow down to specific files. Okay. And here it shows me creation, and then also the timestamp for that. And then on the right, it tells me the time name with the file extension, and then the file type. Okay. So that was when it was created, and then we can further look down. So we can further look down. You also have additional access and saved with the Excel spreadsheet there. You see that? At a later time. And this ties back to the case where somebody actually was phished, and she had sent out a list of like account information with social security number and such to an entity. And what that person, the recipient, he used a fake email account, or they hacked into an email account, and he used that account to forward it to his real account. So the person in the company, she sent out an Excel spreadsheet to him, to this .biz account, without knowing that that was an attacker that was trying to intercept that and use it for something else. So with that case, what they had to do is they have to look at, right, the history in the email, and also the files that ties to the communication with the exchange of email back and forth. Okay, so here it shows you a little bit of the result on the Excel file, right? And look at the user activity in that. With the prefetch file, you would see that you would see the user.dat file, and then additional file metadata that will tell you for that operating system. Okay. And this software has organized and give you the different type of file, so you can sort it by that, or if you, and it's first presented in date chronological order, but we can sort for and filter out specific files that we want to evaluate. And so what they did in the case is that they filter out the .eml file, and they would look into the email communication with the message. Okay, so that's how they were able to identify that the user attached the Excel spreadsheet to send it to Allison M57.biz, because she thinks that that account is still in the network in that same business, but it also tagged it and showed that it was forwarded to a Gmail account that's external. Okay. And so that gives you a screenshot, because she thought that it went to Allison, but it didn't. It went to somebody else. Okay. Any question? So in the event list feature for XWays Forensic, because if you look at XWay, they have other tools as well, but XWay Forensic it's gonna help us pinpoint, right, what had happened and where the file was created on the area of the disk, on the vector. And then from there, we follow the timeline, and we would see what had happened next in the next occurrence. And then we would be able to put a picture together on, you know, this case. Okay. So it gives you the date and time, the artifacts that's related to the dates. So the things that it could do is that it would be able to give you the DAT file, the .dat file, link file, registry file, recycle bins file, things that people put in the trash or the recycle bin, office file, so you saw that it saw the Excel spreadsheet, prefetch file, cookies, because now every site that you visit, they use cookie to gather data. So of course, you know, we can track a lot of the web activity that way as well. And then browsing history and shadow copy on the disk, email messages and so forth. So all of these things would come equipped with that forensic toolkit. Okay. All right, so let's answer the next question. So it asks you, when using XWays in forensic investigation, which feature do you use to establish timeline for artifacts? And you would use event list. And then we simply click on the calendar and we scope down the date range, right? So if you know that there's a case that occurred, the occurrences you're looking at that scope, so you don't need to go outside of that range to, you know, so if you're looking at a certain employee, and if that employee was not hired last year, we don't need to go back to last year, but we want to look at the range where that employee actually exists and operate. Okay. And we would start with the logs. That's kind of give us, you know, the bigger picture on how that timeline should look like, and then we can drill down using event list. So if you're searching for a specific event using XWay with the date and time, then you would use event list feature, click on the calendar, which is what you've seen in the screenshot on the top right with the clock. Then you would select the date to filter. Then once you have that filter added, you can click search, and that will give you a list, and then you can go down that list to look at the file name, and with that you would see the user activity. Okay, so it's simply organize it based on the timestamp for you. Any question? Okay, no question. So we use event lists for 3 and event lists with calendar and date filter for 4. So additionally, now this seems like it might be a little bit of repeat from the last couple of weeks, but these are some of the tools or the suites that you would often see something similar to build timeline. And later on, we'll talk about other type of tools as well. So Autopsy has it, Paladin, I know it has it, Recon Lab also has it. But with Autopsy, you would see this with soft kits. So you would probably, if you experiment with Kali, you probably seen some of the recovery tool, I mean, some of the forensic tool from Kali as well. Okay. So there are open source and commercialized, of course. But these are some of the additional tools that you might want to practice with. And some are commercial, so you might find that they might have a trial version, which has less bells and whistle, and it would only be free for like 30 or 90 days. And then some, they don't have any trial version, so you have to buy it right off the bat. Okay. Any question? And as you know, Python is the preferred language in the cybersecurity world because it's very useful for scripting, right? You're not required to really know a lot of Python, but if you have knowledge of Python, it would be helpful. And there's more to it than just scripting and security, but as you see, there are a lot of tools that were written or scripts that are written in Python. And so if you understand it on how it was created, it will help you through the usage. Okay. So The next tool we're going to talk about is Plaso. And this is Python backend. How we would use this, how we would use Plaso is we would use it to the log2 timeline as a tool to really create a chronological timeline in our investigation. So log2 timeline is a forensic tool, and the way that you would utilize this, it's actually cross-platform. So you have an executable for Windows, you can also run it in Linux, you can also download and install it for Mac OS based on what they claim. Okay, so you can go and make sure you read the documentation. Okay, so let me show you that real quick if you haven't had a chance to see the video yet. But so here's their documentation, and it shows you on how to get started. Okay, now you would be able to use Docker for cross-platform, and then alternative options you can use it, because Mac OS you can use the terminal, so you can use the terminal to install and then to launch it as well. And everything you're gonna see is gonna be console based, so you would have to use commands with it, and then the output is just in console text. You won't have the graphical user interface, so you don't have a UI to be able to click and point like some of the fancier commercial software tool. But this is a powerful tool, and it's used quite a bit in the industry. So we want to learn how to use it. So my recommendation is to use an Ubuntu virtual machine or a live CD or USB like what I said, or you can even create a Fedora virtual machine and be able to run it. But yes, you can use it on Windows. So, you know, I think the screen capture from the text, he runs it on a Windows system. So you would see the executable, and the options are going to be the same with the commands. So here's the user guide information. The link is provided for you there. Okay. And the way it works is we would interface with it using CLI. And if you work with network appliances before, when you're taking like classes at RCC like CIS27A, they teach you how to interface with, you know, switches and router using CLI, right, with their iOS for Cisco. So basically what that is, just a command line interface similar to what you see with command prompt or terminal. And so you would simply issue the command into the CLI to get it to give you some kind of output in the console. Okay. So that's part of Plaso. So here are some of the tools that it uses, or it has. You would have image export. What that does is it's gonna let you export file content from a certain location to another location. So you would export it out, and a lot of the times you would see it as a .plaso, depends on the tool, but we can send a file content from one device to another device. And log2 timeline, which is what we're going to spend a lot of time talking about, that's allowing you to extract the events of the file, so that way we would know what goes first and what goes second and the order of it. So what that does is it creates a .plaso file, which is a database file, and you would be able to use that for analysis. And again, since it's its own extension there, then in order to access it, you have to use it, the application, to be able to open it. The p-info, this is a way that we can display information about that database file that we obtain using log2 timeline. And then p-sort is designed to use with it, so you can filter and sort the content in analysis. And then P still is everything else. So if you want like an all-in-one, the catch-all, you would use the P still. And all of these tools is they're commands, right? So you issue that type of command with the option, so that way you would be able to use the specific. So that's Plaso. So for number 5, how is Plaso used? What are its tools? You would, Plaso is used in command line interface. So in CLI, so you would issue that like how you, in terminal. So if you ever use like this part in Windows for this partition, it's very much like that, right? Like how you would issue the command with the option using the dash. And the tools consist of image export, log2 timeline, pinfo, psort, and psteal. And when you look at the repository for it on GitHub, right, because it's Python, you would see that it's .py. And then you would have different packages to work together, right? So they write libraries and packages to be able to group together as a software package, okay? So with this, what we have is now we would be able to use log2 timeline, okay? So let me come back to number 6. So I want to touch on the type of options that you would use with it. So the screenshot that's shown here is that first, right, first off, you have to have an image, okay? And with that image is how you would be able to, you know, identify the timestamp for the files within that image, okay? So here what you see is, what they're showing here is that the image is exported into Plaso, and it's under the tools folder inside the C directory. When you use the option H is for help. It's gonna list all the other options, so that way you can use it with specific command, okay? And we're able to look at log files, and you have to specify the file name or look at the partitions and partition identifier, or you can even look at the path. So there are many things that we can use with this particular tool. But if you, in all else fails, you're gonna use the -H or the option H, okay? So here it gives you the breakdown on what everything is. If you want filter, if you want to look at a certain file extension, like that way we can narrow down on the type of file that we're working with, right? Or looking at the path, the location of specific file, so you can sort and filter that way, okay? So in the example that they use, this is the screen capture for that. So it tells me here that for the image export, right, this is the command to export the image. With the modifier, we want to narrow it down to where the source is, where the destination, and the specific, which is the modifier. So with the names, we would have this file name, and then where it's coming from is the C drive tools Plaso image, and this is the image name. That's the source, where it's coming from. where is it going to extract the information from. And then once it gets the data, where it's going to put it in is the destination. This is your path for the destination. So if you create, right, if you have like a certain directory where you need to place it, you need to tell it to put it there. But remember that the application is going to want to use the application path. So what they have is they put it here with the files. So after it gets exported, it's going to put it here. Okay. So in the next part is where this is what we need to answer the question. We're going to use log2 timeline. And every single command, it's the executable, and with that you can use the appropriate option with it, and it would have a list of options. So if you don't know what the options are, just type -H, press enter, and then it's going to list what are its available options. Okay. So in this example, what we have is the command structure is that we would have the command itself, the output, and the input. Okay. So where is that going to send to, right? Where is that taking it from, and where is that going to send to? So here's the output portion, and then here's the input portion. Okay. So what it's doing is going to take the image called gene.001. It's going to lay out the chronological timeline based on the timestamp, and then it's going to put that timeline in the gene.plaso database. So if we need to look at it, we need to go in here, find this file under these folders in the C drive to evaluate. Okay. So the screenshot for this is here. So once we execute that, what it's going to do is going to put this in. It's going to have the artifact path. It's going to put it into the Plaso artifacts. So if you want to examine the artifacts, that's located there. Okay. So now we can also apply filter. So let's say that I only want to look at the windows.txt file. So I can do a -F for filter. And we would filter windows.txt. Okay. In the directory under the genefilter.plaso file. Okay, so once we filter, we would put it into here. It would store it under files, export, Plaso, tools, and C drive, or actually here. I'm sorry, that was part of the path. It got cut off. Okay, so we would put it into the gene filter file, and then we would get it from the gene.01 image. Okay, so we have the input, and then we have the output, and we can specify the criteria there. So to answer the next question, it asks you log2 timeline -F filter windows.txt, right? Same thing that you see in the notes there. So it would use the log2 timeline command to extract windows.txt file to genefilter.plaso file. So once it filtered, that's where it's going to put it. And we only filter for that file name and file type, windows.txt. And where is it getting all of this from? It's going to get it from Plaso image gene01. Okay. So it's going to pull the file filter information from the image, and it's going to put it into genefilter.plaso. Okay. So here we have source, destination, what it's doing with the option, and then file name. Now, this is a simple process, right? But in the case where if you're looking for more of the broader general file, you might find that it would go on for a long time. Okay. So even if we filter, we scope it down to a smaller range. But if it's more of a common file, then that might take a long time. Any question? Okay, we're halfway there, so hang tight. Okay. So there's additional screenshot on what it would look like when you filter this, right? And the output, what's expected. Okay, so if we want to look at the filter, we simply would go to the exported, the .plaso file, okay? Okay, so in that database file, this is what it contains. The time when the user executed the tool, okay? If there were any options that were used for the tool that was ran, the information for the pre-processing stage, the metadata, what was parsed in the parameter, the events, how many that was extracted. So that could be multiple events, and then the tag events. Okay, so it's kind of building the background on the time that you ran the tool, the options that you ran it with, the information, how it puts the information into that database in pieces, and then also how many events. Okay, so it would list the extracted information. So to really dissect and look at specific information, we would use the pinfo command. Okay. So if we use the pinfo command with this database file, it would give us the information about that particular database. So you can get storage information, you can get file information using that Plaso file. So simply using pinfo. So first, what you need to do is, number one, we need to export the image, right? So Plaso can access it. Number two, we need to use the log2 timeline command to create the file, the database file, the .plaso file. Then third, we would use pinfo command to look into the database file. Okay, and if you don't get what you want, then you would use psteal, which gives you a larger set of options. It's like a catch-all. Okay, so it shows you, and then psort and pfilter just kind of allows us to sort down the file that it found, okay, or information that it found. So this will give us filter option, sort option, so you can do analysis of the content inside that database file. Okay. Any question? So we have answer number 6. So for number 7, it says, which Plaso tool can you use to get storage information about the file and how many sessions were used to create it? And we would have pinfo. And then the following tool, which is the sort. In Plaso, which option in psort you would use to output format? And this is O, so I'm jumping ahead here, right? So pinfo give you the storage information about the file, how many sessions that were used. Remember that it's looking for what? The MAC, right? Okay. Create, access, and modify. So with psort, we want to filter out the information we don't need, and we can have it output format. So the option O here just indicate that it's going to be output, or you can simply type out -- output. And if you do that, you have to follow it up with the proper syntax. Otherwise, it's going to catch it as an error. So we would do a dash format. That's the simplest way, or we can use the other ways here. Okay. So we would have it output a certain way, so that way we can look further into that. So if you want CSV format, which is very common, right? We would be able to format it with only, we would search for the format CSV only. Okay. Or if you want other type of format, you would specify it. So the reason why that they chose to do this is that they're looking for that Excel file, right? In the case where that spreadsheet needs to be located based on the data leak. So we can identify by filtering it down to a smaller scope. And a thing that would be useful is to do analysis plugins. So in psort, it tells you that you can use an analysis list. This allows you to extract and analyze the content of the file. Okay. So this is, it's going in as a modifier. Now, we remember that when we do this, we don't want to just open up the file manually, right? We want to use a software tool, so when we look at it, we don't change its state. So with the plugins, it looks like this. Okay. And since this is a more of a recent tool, you would see that it has a lot of the functionality for more current type of investigation. Okay. So you can analyze browser search entries. With this plugin, you can also look at Chrome extension for the connection. You can look at hashes. You can look at hash values for the evaluator labels, tags, and so forth. Okay. So based on the timeline, what we can do is we can drill down to the specific. And this is a plugin for psort. Okay. So all of these tools are used together, actually. Any question? So here, this is a command that they use with psort. So the option, they don't have any additional options for the O there, but they want to add the analysis plugins, and they would use it for tagging. So looking at the file tagging and tag the Windows text. Okay. And here is your database file. So you have to create it, and in order to look into it, you would use pinfo and psort. Okay. So here it produces 9,000 and something tags based on that for the analysis report for that particular windows.txt file. Then it shows you on how you can create the event by slicing it. So what would that do for us is it's gonna really look at what had happened since that marker point, right? This is the time that we want to put a mark on, so we can narrow it down to that window of time. And so we can slice it to that time window, okay? Then pseal, like I said, is everything. So if you're not getting what you want in the specific tool, you can use pseal. And here are the options for its command. We can look at buffer size, process, storage, archives, credential, so many other areas. Okay. Any question? Okay, so outside of Plaso, you can also use other tools, and there are links to them for most of them at least. So you got the Elk Stack, right, which is from 3 different projects combined. So they had created this legacy-wise, and then they combined it into one, which is gonna be, you know, Elk Stack. So you can look at elastic.co there, Logstash, Timeline Maker. Some of these are commercial and some of these are open source, so not all of them are free. Okay. And then some of them you have to use it with a certain thing, and so you should look into the documentation. So we had talked about Plaso, right? And this tool, some tool will work with Plaso and some don't for analysis. So you can do the Timeline Maker Pro. You can use Time Sketch. So these are some of your other options. Okay. Okay. So let's answer the next few questions. So for 8, we put down that we would use the option O, right, to output for our format, and could be like the type file format. Okay. And then the tools for creating timeline, you can pick any of those. So part of this certification will also address the process in the investigation, and they would ask questions about your timeline, how you would create the timeline. Okay. Any question? Okay. We just have a few more to go. Okay, so a big chunk of the digital forensic ties back to media. And we spent a couple chapters on it, especially, you know, the last one we talk about file system and partition. And, you know, so this is kind of like a review of that, a summary of it. Okay. So in media analysis, so media, I would point back to storage devices. Okay. And in some cases, that would be RAM, right? Because some systems don't have a permanent storage. It would just have a temporary storage location, internal memory, or could be RAM. So when you analyze media, you should look into allocated space, which is what we would see when there is a volume, there's a partition, right? It could be primary or active or extended. So that is use space. Allocated space is use space. Files actually occupies this area. File system recognize the storage space. So when you open up your disk management console or some kind of management console to look at your drives, right? If it shows up as a recognized drive, that will be allocated space. Unallocated space is space that's not used, right? So when you delete files, it puts it back, or if you delete partition, you delete files, it releases that space back into the unallocated space. So that means that it's not occupied by file. Okay. The file system sees the space as available for use, but the file can still exist in the unallocated space after it's deleted. Then you have slack space. We talked about cluster last week, right? And that would be a group of sector. So when it cannot fill it on one cluster, right, there's extra, the remaining space is not used, that will be slack space. Okay, so if it doesn't fill the cluster, there's a little bit of extra that's left in that cluster, that will be slack space. Okay. And then if you're looking at bad blocks or bad cluster, that would be considered as defective to the file system. It can also be used to hide data. So we would also need to look at bad block or sectors. Okay. So for 10, it asks you, when you examine the media, what areas should you examine? We said allocated space, which is used space for files. Unallocated space, which is unused space, free space, available space. Slack, which is leftover space from the cluster. And then bad sector is defective space. So all of, everywhere, right? We basically look at everywhere on the media. That's basically covers the entire media. Now, so then how do we narrow it down, right? Timeline, file name. Timeline gives us the date, and the date tells us the file, and that's where you will be able to filter it down. Okay, any question? So there's a famous forensic investigator, and this is how he suggests when you're looking at the media. So we are going to zoom out from outside in. Okay, so first we're going to look at the physical storage, which is the disk. That could be like flash drive, hard disk drive, SSD, micro SD. So from that disk, which is a physical storage, then we're going to narrow down to the container, which is a volume, or could be spread across multiple disks itself. Okay. So you might have volumes in one single disk, or you might have one volume that span over a group of disks. So if we're looking at RAID, right, that could span across multiple disks. Or if you cut section of your disk to create volumes, so you would have multiple volumes inside one. So from the volume, we're gonna go zoom in on file system, FAT, NTFS, Linux file system like exe2, 3, 4, etc. Okay. I think I have mistyped here. So from the file system, then we can go down to the data unit, which is a smallest unit in the file system. So we have disk, then volume, then file system, then data unit. Okay. Then with the data, we would have metadata. So this data about the data, right? It was modified, accessed, or created, the date, the timestamp. And there are ways to modify the metadata too, and you saw that previously, right? So sometimes this has been modified, but the system, the way it's designed, is also logging that, right? So if something is modifying the metadata, then the system will log that. So the data has its own metadata, which tells the system of what it is, what it was accessed, when it was accessed, and so forth. Okay. So that's how we can narrow it down to the unit and then see what's in that unit. So for the next question, 11, we need to look at disk volume, file system, data, and metadata, top down. Okay. So how do we find the data, right? We would look at the timeline and then narrow down what type of data or what type of file. So then we would go and look at the information about that data. Okay. So first we have the image. Inside the image, we will look at specific location, the file system, the data, and the metadata. Any question? Okay, so let's talk about string search. And very much like a lot of the tools that would entail searching, we search for the data, we search for the file. So a lot of these software tool allows you to go in and issue specific search. And in this textbook, it talks about how you should categorize it so that way it would be easier. So if we can understand how the software is designed to be searched, then it will be easier for us to issue the search. Like I know that like a lot of people know how to use search engine, but a lot of the times people just type in anything. Okay, just sidetrack real quick. Interesting. I listen to talk radio sometimes, and a while back, there's a researcher that he studied. He researched for Google, and he studied what people type into Google as, you know, just to search. And surprisingly, he mentioned in his segment that a lot of people, they type in their feelings into the search engine, right? Like sad, happy, right? Like how to fix those feelings. So, you know, and then they would use that data and they would, you know, build some analysis out of it. And this is how Google would come up with ways to really advertise things to people, like give people ads at the beginning and so forth. Okay. So anyway, so when we search for forensic, we have to have a technique. So we would use keyword, or we would use specific term, possibly for file name, or, but what if you don't know the file name? You have to search, right? So it uses string search, and if you learn about programming or development, you might have a little bit of background in this, but if you don't, that's okay. Okay. So we know that we have to look at different areas of the space, right? Allocated space, unallocated space. So we have to issue the string so that way it would look, right? The software would look. And the best way to do this is to break it down into category and to use regular expression. Okay. So there are two categories in how you would use keyword listing. One is just generic. Okay, the keyword that you would use for every case. So that would be subject of your investigation. Okay, and the example that they use here is for fraudulent type of case, they would look for activity, keyword that would relate to activity. Okay, and then or keyword that would be for illicit image. Okay, so that will be a general keywords list search. Then you can have case specific. Then you would use keyword that's based on participants, location, slang. So would be, could be participant name, or it could be a location, city, address, and so forth. Username, watch out. Sorry. Username, and then address and physical address, phone number, credit card information, etc. Okay, so that will be case specific keywords. Okay, that will be the answer for your next question. 12 is that you can use generic keyword list or the case specific, and case specific pertain to the entity in that case or the information that ties to that case. And then if it's generic keyword list, it'll just be a word that might relate to the nature of the case, like fraud or, you know, things like that. Okay, so how do we use regular expression and what is it entailing? So we know that there are two main encodings. So we have the ASCII, which is character encoding for text, and it's limited to 256 character codes. And then you have the Unicode, which is to overcome ASCII limitation. So that will go up to 65,000 characters. okay? Now, if you're familiar with programming languages like JavaScript, Python, or even C++, you might hear the term regular expression, okay? So regular expression allows us to add in symbols, characters, and specify that, so that way when we search, we can look for specific, digits or values, or could be text. So, and regular expression allows us to narrow down to specific pattern, like only digits or only characters, or things in range. So here it gives you a list to use for instances and patterns. Okay, so if I'm using the asterisk in front of any characters, okay, that would just allow me to have repetition. Okay, so if I do like CA asterisk T right here, that could mean CAAT, CAAAT. So I can have a repetition of the A before the T. Okay, so this list is useful if you want to match the number. Then you can use the hashtag. They say pound sign, but it's hashtag, right? The hashtag backslash following certain things. So there's some example for you. The caret 1, 2, 3 would start with 1, 2, 3. So if I want to have the search result to give me the start value of 999, right? I would use caret 999 in my search. Okay. Dollar sign matches with the ending. So caret is the beginning, dollar sign is the ending, plus symbol is that it would be one or more, and so forth. Okay, so it's a long list. You can look at the list. And then we can use the dot, also known as a period, right? So we can use the dot to take any character. So that will be wild. Okay, that will be your wild character, is the dot. And then the question mark is when we're not sure if there's certain character is present or not, right? Like we don't know what would be following that, so we can also put the question mark. And then the pipe is for any character that's separated. So that would be the separator indicator for the match. So here's some example. So when I teach the JavaScript class, they have a unit specifically for this, for user input and validate, to make sure that they input only digits, only characters, etc. So it will look something similar to this. So this is an example of searching for only an IP address with the regular expression. So we know that the /D indicates that will be digits. That means that it would only be numbers. And then you want to put in the curly brace that it would be 1, 3, indicate that it could be 1 to 3 digits. So if you're looking at social security number, right, that's all digits, and it's the first part of the social security is also 3. So we can use it something like that for social security. The slash and the dot here is to indicate the period character. So it's going to look for period, because with the IP version 4 address, it might be like 192.168. Let's say 0.1, right? So it's going to look for 1 to 3 digits and then the dot. Okay, so this part right here is the dot. Okay, And then this part right here is the numbers in the front of that. So you can see. So this is for IP version 4, and then the IP version 6 is slightly different. We just got to put in the criteria for the search for that. So, and you would repeat this because IP version 4, right? It's a 32-bit address, and so each of the section is called octet. Then, so the 192 would represent the octet there. So we would have each octet search as /D 1,3 in the curly brace, and then /dot. And then we would repeat that for the second part and the third part and the fourth part. That would conclude the 32-bit. Okay. And then this is an example for search US phone number, right? Because you have the area, the country code, the area code, and so forth. So this gives you the breakdown for that. Now I only included 2 examples in this, but you can look at the other example if you have the textbook, or you can also find example for regular expression, how that would be used. Okay. Or use the symbol list that they gave you. Okay. Any question? So the symbol that you would use in place of any character is the dot for number 13. So if you're not sure what character needs to go there, you can use that dot. Okay, so the last part we're going to review real quick on how to recover delete data. Last week, the whole chapter was on FAT and NTFS file system and what the file would look like. And when you did your lab last week, you saw this, right? When the file was deleted, we saw that it puts the 00. That means that it just resets that hex value to indicate that that now is available to rewrite. So when you're looking at the directory entry, if it changed from a hex value to hex 00, you know in the FAT allocation table, you know that that was a deleted, or it's an empty location now available for something else. Okay, so first you've got to compare the hex value that was previous to the updated table entry. Then we also need to look at the process in reverse to make sure that the file content has not been changed. So we have to look at where they are in the physical cluster. And going back to the file system information, it has the boot information, has a lot of the details on how the clusters are divided. Okay. So first we have to look at the first cluster. And the first cluster tells you the file of the file size, right? Which cluster is in the first cluster for the file, so where it is in the cluster, the file size, and the size of the cluster in the volume. Okay. So here it shows you and it gives you the explanation. Now when it's changed, right? If you wanted to test a modification in this, you would use the hex editor to do that. And if you modify the hex E5200, right, it shows you on that software where that cluster would be. So that's the fat. And then there's some additional screenshot. So now when you're looking at free space, you're gonna see that it would have 0, 0, 0, 0, and then you would have for the boot, it would also indicate that, right? And the record for the boot, we know that it needs 512 or less, and 8 sectors per cluster. And for the cluster size, that would be 4096 bytes. And this was all touched also in chapter 4. So when you delete the fat, as it's shown there, you're going to get a bunch of zeros and Fs. And then at the end, you would have an F8 to indicate for the cluster 8, the cluster number. That's fat. Okay. With the NTFS, what you will have, and they have a short section on it, but in the last chapter, it goes into the detail on how to look at the NTFS file. So anytime that you create a file on the NTFS volume, it uses the MFT file metadata information. So the value is changed with the MFT. And it uses this NFT record to really keep the inventory of your file and directory. So when the content of the file, or if it's a non-resident file, it's going to show it with the little $ symbol to update that cluster that's occupied on the allocated space. So now, even if the file, once it's created, it will increment by 1, right? So when it deletes it, it still keep that increment. So let's say that I have a file 1 deleted. On the next file that's created, it's going to say 2 for that MFT. And then when file 1 is deleted, what happens is, again, it's going to also free up that space, but it's going to keep the MFT value as incremented for all the subsequent file. Okay, so that's how it's able to track the inventory of that file. So when you want to find the deleted file for the NTFS volume, you need to really locate the MFT file entry in the unallocated cluster. Okay, so the unallocated cluster will indicate 0, 0, similarly to fat. And on the software, when you click in that section, what it's going to do is going to say, and at the top, you would know what kind of file system it's using. It's going to, for the boot, it's going to say 00 NTFS, right? And that means that you know what kind of file system it uses. You saw that in the last lab. So in the unallocated space, it's going to free up those space by saying that these zeros, right, hex value is going to be available. So the existing MFT will always be incrementing up by 1 based on once it's created. Okay. So even when, so in the case I'm looking for the file that was deleted, then I should look at the existing file incrementation and do or increment it by reversing it and say, that means that it was deleted. So if I have 1, 3, 5, well, 1, 3, 4, 5, 6, 7, 8, 9, 10, that means that I'm missing 2, and 2 is in the unallocated cluster. So I can go and locate that there. Okay. Any question? Okay. No question? All right. We finished about 30 minutes early. If you don't have any questions,